So I'm going to be talking about what I learned about functions.
And pre-calculus.
To start off with, what even is a function? Let's think about something you probably did back in 8th grade. That is, graphing linear equations. You probably remember graphing a line that looks like this. I want you to think about how this function works. And what I mean is, how does the function kind of graph itself? And one concept you guys might think of is that this line is constructed of an infinite number of points. And where do those points come from? They come from the function, obviously. It's the function that takes in an input and gives an output, which is the point on the line. Some functions can have multiple inputs for a single output. You guys might have seen the graph y equals x squared. On the graph, you can see that when x equals either 1 or negative 1, the y value, or the output, stays the same, 1. Knowing that, a lot of graphs can be considered functions, such as this graph, or this graph, or that graph, or this graph. No, that's a relation. The reason why it's called a relation is because that when you put in an x, there can be two outputs, which is not the definition of a function. That is the reason why functions, all of the functions actually, have just one y in their expression, because any input it only has to give one output. The inverse of trig functions like this one is also a relation, because when you put in a value like √2/2, you would get two angles in the circle, in the unit circle. So that is two outputs, and that makes this not a function.
We haven't been talking about inputs, so let's talk about inputs. So what are they? Are they just like random numbers that we just put into the function? Or could they be more specific? Could some inputs not make the function true? And you're right, there are inputs that don't make the function true. That means there is a set of values that do make the function true. We call these values, or these set of values, solutions. These solutions, simply put, are simply values that make the function true. And what I mean by that is that when put into a function, it makes the function give out a value. In a more general term, solutions are basically just any number plugged into an equation or a function that makes a true number statement, right? Even in our last example, we can see that when 2 is inputted into f of x, we can see that 7 equals 7, right? Which is a true number statement, meaning that x equals 2 is a solution. So if those are solutions, what are the things that are not the solutions? And how can we know that they're not solutions? In the world of pre-calculus, you will be encountering a lot of equations and functions that when you put in a certain input, the function will not be true. Let's look at tan of x, for example. What kind of inputs can I put into tan of x that makes this function not give a value or not be true, which are both synonymous meanings, but if you haven't yet, you will soon learn that tan of x represents just a fraction of sine over cosine. And it might come to you that any fraction over a 0 is undefined, correct? That means whatever input we put into cosine of x in the denominator that makes cosine of x equal 0, we basically found a value that doesn't make the function true. That is why it's called undefined, because the value is not defined. As you journey through pre-calculus, you will be introduced to a lot of new stuff. You might encounter parametric equations, or logarithms, or maybe even trig functions if you haven't learned that in Algebra 2. But a lot of the ideas that I've explored personally were all just relating or revolving around the idea of a function. And as you explore into this new idea of parametric and polar equations, you will see and realize that there are these type of functions can do the work that other functions cannot do. You might remember at the beginning of the video where I showed you a circle and said it wasn't a function, right? Well, that's because it was a rectangular function with the equation y² + x² = 1. And before you learn about parametric and polar equations, you might reasonably think that it's not possible to graph a circle with just a function, right? Well, now, after you learn about parametric and polar equations, you will see that graphing circles is completely possible, just in different forms of functions, or different types of functions. And believe it or not, this polar equation that you see here is equal to the rectangular equation y squared plus x squared equals 1. Just that one of them is a function and one of them is not a function. Well, what does equal mean or equivalence mean in this context? I mean, if you look at r equals 1, you can, and compare it to like y squared plus x squared equals 1, you can obviously see they're not equal, right? And they don't even give the same values. It's just r equals 1, and then for the rectangular equation, y and x can be anything. And you might be right that they do look different objectively, right? But it's not that they are different in their entireties. They're just functions in different forms. If you convert r equals 1 into the rectangular form, you will get y squared plus x squared equal 1. And vice versa. If you convert y squared plus x squared equals 1, you will get r equals 1. So when we convert one of these functions into the other, we will see that they have the same form. And because they have the same form, they will, whatever input value put into them, both of them will give the same output. That is the meaning of equivalence. So as you learn pre-calculus, you will mostly deal with topics that are related to functions. And I'm not saying the whole course is about functions. You will definitely learn a lot of something else. For example, you will start dealing with sequences and series. You will also be dealing with vectors. And for most of you, you will be introduced to matrices. All of these are simply different ways of writing like stuff, and some of these give us a new introduction on how to solve problems differently. So to summarize, one of the big parts in pre-calculus is functions, right? And a function is simply just an expression that defines a relationship between one variable and another variable. Usually one variable is dependent on the other variable. And a solution is any number that's plugged into a function that makes a true number statement. We covered that over the examples like 7 equals 7. Equivalence is when two things are the same. That's the real world definition. But in math, it can mean when two things can give the same value, graph, or an expression, something like those. But those three things are the core ideas of pre-calculus.